Hello, and welcome to this tutorial on creating billboards for 3D printing using generators. The goal of this tutorial is to introduce you to the capabilities of this generator and to explain the function of the various options. Just as a reminder, my generators are available for downloading at my website, http://dackm.github.io. Right below my introduction, there is a table of contents, and in the entry on Automating CAD is a link to download a zip file containing all the executable files. Before we start discussing the generator, we need to make a few assumptions. We will assume that you have successfully downloaded the generator zip file, extracted them, virus scanned them, and launched the Billboard generator. We will also assume you have learned how to post-process the SCAD files through the Open SCAD program to create stereo lithography files. If any of these assumptions are not correct, please watch the tutorial on creating a basic building where these concepts are introduced. Next, we will assume that you have already searched the internet for billboard artwork, saved desirable images to your hard drive, resize them to a size you like. For example, if you want the artwork to be 8 feet tall in HO scale, that corresponds to a height of 28 millimeters, and know the width of the artwork as well. Finally, we will assume that you have printed your artwork on decal or cardstock material. If these are not correct, please watch the complete video on building billboards where we present how artwork may be collected. As a reminder, the default values of all parameters represent good starting values, and if you are new to a generator, I recommend starting out by just clicking on the green Generate button to see how things work. The green button will ask you for a location to store the SCAD file, which contains the 3D instructions to create your desired object. And to terminate the generator, just click on the red Exit button. The maroon and blue buttons load and save the configuration parameters respectively, and the orange button restores the default values. Now take a look at the radio buttons at the top of the form. The billboard generator can create 4 different types of objects: a face frame to hold the artwork, a leg set, only a single set because you can print as many as you want in your slicer, a boardwalk, and an assembly fixture to facilitate gluing the legs to the back of the face frame. So just click on a button to make your choice. Let's start by examining the parameters in the face frame area. We have assumed you already have downloaded or prepared your own artwork and know its dimensions in millimeters. So the values in the upper left are where you record the width and height of your artwork. To the right of the artwork dimensions, you see a substrate thickness parameter, which controls the thickness of the panel behind the artwork. Something around 2.0 millimeters works well in HO scale, and perhaps 1.2 millimeters in N scale. You are not absolutely required to 3D print a face frame. You could just cut a piece of styrene to size and be done with it. But the legs, boardwalk, and assembly fixture parts gather much of their data from the face frame parameters. So at least to start, I recommend letting the generator create the face frame. Most billboards have frames around the artwork, and here you specify the width of the frame boards and how thick they are above the substrate. There is also a field where you can specify an amount to elevate the face frame above the boardwalk to give the paper hanger some space for his toes when hanging the sign. Now let's consider the back of the face frame. Many billboards have horizontal stiffeners to give the face frame rigidity. So how many do you want? And how wide and thick should they be? And how far apart should we place vertical stiffeners for the legs? Remember, the defaults are always a good place to start. The leg parameters are considerably simpler than the face frames. There are 4 pieces in a leg set: a vertical leg to which the face frame attaches, a slanted leg displaced from the vertical by 30 degrees, a horizontal piece on which the boardwalk rests, and a diagonal piece connecting the main legs, just below the boardwalk. So, how big should these beams be? 2 millimeters square looks good to me in HO, but the choice is yours. You also get to choose if the boardwalk support should be in the same plane as the other legs or offset. Offset is prototypical, but if you choose to do so, you will need to enable supports in your slicer software when printing, which for some printers, like Creality's, can be problematic. This is really a nuance here, so don't worry too much about it. Finally, if the boardwalk is less than 8 real feet above the ground, you may want to eliminate the small diagonal brace between the legs. The boardwalk seems so simple in concept, and yet there are so many parameters in its design. We just need to specify the number of boards we want, their width and thickness, and how far apart each should be. Then we need to attach them together with cross members, or stringers, so we need to tell the generator how many of these we want. Something between 3 and 5 looks good for HO. And if we want the stringers to be in the same plane as the boards or below the boards. Finally, we need to specify how far above the ground we would like the boardwalk to be. 28 millimeters corresponds to 8 feet in HO. The last object this generator can create is an assembly fixture to facilitate attaching the legs to the face frame. I created this fixture because I had difficulty in keeping the legs perpendicular to the face frame when gluing. This fixture requires no additional parameters beyond those we have already discussed. Each fixture is custom designed to fit the sizes and spacings you have entered. But if you do not change the size of the legs, or their distance from each other, or the size of the boardwalk, you can probably use the same assembly fixture with a different sized face frame. To use the fixture, just insert the boardwalk support into the vertical holes in the fixture, then press the legs into their slots, but not quite all the way. Slide the face frame face down into the large flat area, making sure to not force the frame into the area reserved for the toe gap. Shim the face frame if necessary. Finally, apply glue to the vertical support area on the back of the face frame reserved for the legs, and lower the legs into place. Just be sure to avoid getting glue on the fixture, or you will be obligated to print everything again. That's it, the Billboard generator in a nutshell. I hope you enjoy the program and find many uses for it. Have fun!